Hello everyone. In this video, I'm going to demonstrate an automated Excel tool for analyzing our living data. This workbook creates a complete dashboard, a 12-sector directional analysis. So, as mentioned before, we are going to use the VBA inside Excel. So this is our input data. We have three columns. First of all, column A goes to date, and column B goes to mean wind speed, and column C goes to wind direction. Our temporal resolution is 1 hour. It means at every 1 hour we have one data set. So we have totally 1 year data. So it means we have totally 8,740 data sets. This tool can process several years of measurement, including datasets with more than 100,000 records. But for our example, I have considered just 1 year. This is our sample data. At the end of this video, I'm going to give you the Excel links and also the files for all modules in VBA. So first of all, we have three modules. The first module goes to create our dashboard. The second module goes to create directional analysis. And the second one goes to calculate Weibull parameters based on WASP method. Okay, now to add the first module, go to Developer tab and then click Visual Basic. Okay, now there we go. Right click here on Microsoft Excel objects, right click and then insert first module. Click first module. Okay, there we go. First module is there. Now I have created the Visual Basic functions. So it's a text file. You are given this text file later, but now I would like to copy paste this VBA functions directly here. So there we go. Our functions ready to use. Just save this module. This is module first, which we are going to use for dashboard. Just click save. Okay. Now you can close this window. For the second module, for directional analysis, please repeat again. So go to module, right click and insert the new module. And then I have the source file. I have the source file, so Control V. There we go. So we can use these VBA functions in order to calculate here directional frequency. So save this module. For the last module, repeat the same procedure. So insert, click module, and then Control V. So this is the last module in order to calculate Weibull parameters. So this is the last module in order to calculate Weibull parameters. So now I have already created three rectangles, so it's so easy. You can go to insert and then create shapes. You can create a shapes. Okay, there we go. Now you can right click here. You can right click and then assign macro. So in order to different calculation, you can assign your desired function here. For example, if you would like to handle to create the main dashboard, you can choose this option, choose create wind dashboard, and then click. From now, if you right click here, click edit test, you can add your functions, for example, directional analysis. Exactly. So now your text is ready. If you click here, the first module will be executed. So I can click here, directional analysis. We have our dashboard. So different figures and illustrations. So the main dashboard summarizes the complete measurement period. Key indicators here include a number of valid records, average and maximum values. And also we have different graphics like wind frequency distribution, radar chart, monthly wind distribution, diurnal wind distribution, wind rows. So if you go to this tab table worksheet, then we have all calculations in details. For example, wind frequency distribution versus 12 sectors. Here we have also the yearly distribution of mean wind speed, temperature, and also wind rows information, wind speed frequency in 12 sectors in different wind speed ranges. So for the next functions, you can right click here and also assign your new macro. Click assign macro, and I would like to assign create directional frequency for this rectangle. And for the last one, for Weibull calculation based on WASP method, right click here, assign macro. So I would like to create WASP histogram here. So select this module and then click OK. So now there we go. If you click directional analysis, the next calculation is there. We have directional analysis. So this is the wind. This is the standard template for wind frequency distributions. This we have different wind speed ranges and also 12 sectors. So beside this, we have different graphics in 12 sectors from N. This is 0 degrees to the last sectors. And for all sectors, we have wind frequency distributions. So sometimes you see the vertical axis needs to be modified. If you would like to modify anything, you can click here. For example, click here on this vertical axis, right click here, click format axis, and then go to number and choose category percentage, decimal places 1. It's good enough. Okay, there we go. So it's modified. There we go. This wind frequency distribution is so important for energy calculations, and also later if we would like to create Weibull distributions, we need definitely this wind frequency distribution. Now go to raw data and then click Weibull calculation to run the last module. Click Weibull. So there we go. So we have Weibull parameters in 12 sector from N to NNW. Each sector is 30 degrees. So we have Weibull parameters, scale parameter A in each sector, and also K parameter. For scale parameter, the result would be 7.4948 meter per second, and K parameter is 1.6436. So notice that this Weibull calculation follows a practical WASP histogram fitting approach. A separate Weibull distribution is calculated for each 30-degree direction sector. And notice that all values already validated based on the original WASP methodology. So you can easily trust on these values if you would like to use them later for your work. So for WASP calculation, several quality indicators are included. So RMSE and MAE given here, those can compare the observed and fitted frequency across all the speed bands here. For example, for this case is 0.4%, which is so low and acceptable based on this method.